Good afternoon. Welcome to hi Noel. Welcome to today's lecture, right? So before we start, right? So I just want to bring your attention to a couple of announcements I've already made. Right? So just let me display it. Right. So you should see on the screen. Okay. So this week 4, yeah, this week is week 4. We have dry run. Okay, dry run, just testing, yeah, but we still need to do it so that there is smooth running of our midterm tests. Okay, so dry run is just for us to get used to it. I know you guys already maybe a bit familiar about how we conduct online, yeah, but still to be consistent with other branches and main campus, we will conduct this simultaneously as well. So this will be conducted tomorrow, okay, Tuesday, okay, between the time of 5 to 5:35 p.m., right? Okay, so the time, date and time should be okay with you guys because we already provided our timetable to our CC, yeah? So she has uh, I think pick this time as the most suitable, okay, for simultaneous conduct of the dry run,
Oh,
right?
just dry run only.
Yeah, this is the dry run this week. Tomorrow, so dry run. So this is the itinerary for that. Okay, so dry run only, yeah. Don't panic, yeah. Now this is the real thing. Okay, so notice it's week 5. This should give you another week to do your revision. Okay, your revision. So please note the chapters coverage. Okay, in fact, we already completed since last week our lecture and our tutorial. If you noticed, I made some comments, either is to correct or to provide more information, more relevant information into your tutorial. So please do go back to our previous tutorials. It's all the link all available, as you know, in our classwork in our Google Classroom. So chapter 1, switching concepts, virtual LANs on chapter 2, chapter 3, inter-VLAN routing, and spanning tree protocol, right? So today we're gonna continue on chapter 5, which is the EtherChannel, right? And after our topic on EtherChannel, I would like you to make use of the tutorial session, right? To do some uh, revision. Yeah. Okay. So for that purpose, I've already shared 3 partial exam paper, right? So let's just have a look at one of the exam paper. For example, this is September, and then after that December, and the most recent one is April, May this year, right? Right. So if you notice, the question is very similar to what you have in your tutorial. Yeah. So let's take example question 1. Briefly explain the term broadcast domain, right? And then identify, right? Identify how many broadcast domain. Okay. You may or may not be asked to circle, just like in the tutorial. Okay. Uh, and uh, and this one is the again question asks you to look at the MAC address table, right? And then I think this one, I think you should recall that we've done this as well. But I'll briefly explain switch steps in order of your occurrences. Okay, what happens, the ingress, egress, and the checking of telemetry.
Oh,
Yeah, so this one we've done already, can? They give you the MAC address, and then this is basically mapping between MAC address and to the port on the switch, right? So you just describe the switching steps, right? So you're given with the source and destination. What happens if it's not in the MAC address table? What happens if it is in the MAC address table? So Yeah, quite similar to what we've done in tutorial should be okay. Please refer to tutorial question answer again if you need some recollection, right? So and then again some question here says that and explain which switching method ensures incoming frame is error free before forwarding. If you recall, there's on the layer 2 there's a on the trailer side there's a checksum, right? That's the one, okay, that allows the switch to check whether the frame is error free. So your answer should be based on that. For example, for these 3 marks. Again, here, as you can see, a lot of questions is this type rather than the explain, discuss, or things like that, right? So you're given a scenario, okay, and then you're asked to answer, right? So I would like you, and this is one, and then another one is very similar. This one is December, so you can see, right? Okay, collection domain, broadcast domain, again, right? If you notice, it's a different scenario, but similar way to find out what is broadcast domain, what is collision domain, and so forth. Again, September, please just look at questions and attempt or try out those questions within the 4 chapters up only to STP, right? Only up to STP.
The questions just like midterm just the past year question around the same.
Oh no, they're not going to repeat the question.
No, no,
Well,
I mean the kind of the format
similarity,
similarity.
similarity.
Yeah, the
Yeah, quite
style of the
similar.
question.
Yes, quite similar to this. If you notice, our tutorial question is similar to this as well. You're given like a topology, you're given a diagram, and then you're asked to either answer based on the scenario, right? So looking at the partial question is also the same. You can see that you're given the scenario and you're asked to, right? For example, here you asked to circle collision domain, same as you did in the tutorial, right? So that's why I save you trouble to go and download. I upload here three the latest ones, okay, so that you can look at it and practice, okay, practice and do your revision, okay. So we we only do up to chapter 4 chapters, 4 chapters, okay, which is up to STP only. Okay, so I think should be okay lah. Should be okay as long as you know to if you know how to answer these four chapters. Then I believe the midterm test should not be a problem. It is when you look at a question that you have no idea what you did, then that's a big problem lah, of course. So all you need to do back again to do revision, check out the notes, the slides, go back to if you need, you can use NetAcad. In fact, this test is going to be open book, right? So that should make it a bit easier for you guys. Okay, but don't rely too much of only checking for information during the test because you will run out of time. So I suggest you do prepare. Okay, like I say, before this, since you know what's coming out, right? So you know one of the skills you need to pick up is how to summarize your information. Okay, whether you're using manual notes or digital notes, or you know how to quickly, okay, find or locate those information relevant. Okay, if there is any questions such as explain or discuss, please use your own words. All right. So the plagiarism is set as 10%. Okay, below 10%. Right. Any questions?
No.
Okay. All right. So I really hope you guys will do all right now since you
Oh,
see 1
only
week.
half an hour to do the questions.
Oh, half an hour.
Oh, it says the time 5
This
to
this one, this
5:30.
one, this one.
Oh, I
I
mean
think
the dry run.
the dry run or the dry run we can end it quicker lah because it's just a dry run. This is just to show you guys the steps what we're
Okay.
going to do in the so that we can focus on the actual tests. We can focus more on the answering the question rather than focus on the technical things like, oh, now we have to do this, we have to do this, so you guys already well versed with it lah, right? Okay, so but it does seem like you only have 1 hour. Okay, can you notice that this info I got from our CC, so I believe this is accurate lah, right? So notice that it's 1 hour, 5:15 to 6:15. Okay, right? So you really need to be prepared. Okay, be prepared. So the good thing is you still have 1 week. Okay, so later during the tutorial, please um, use the time to we can continue the normal tutorial, but tomorrow, if you still need maybe tomorrow tutorial also, you can always catch up in the tutorial. But I really want you to do your revision. Okay. Um, I think I forgot already, but I think this one is, if we recall back the course file, syllabus actually mentioned how many percent is it? Let me just check. Yeah, it's about, if you see that it's 60%, that is about slightly less than 50, about 40%, I think, 40-60%, right? 40-60%. So 40% test, 60% practical, right? Okay, so practical is another issue, but since that is in the future, as long as you keep on doing your practical tests, um, we'll have some revision for the practical test as well later on. Okay. All right. So let me continue now with our today's topic. So let me just stop this and then I'll record. Yeah. As usual, if you find yourself have any questions, raise up your hand or just unmute yourself and ask.
Okay.
All right. Okay. I think, yeah, you can see it. Okay, let's proceed. So this chapter 5 is from module 6 from your Net Acad online resource, yeah, and it's called EtherChannel. Right. So in this chapter, the topics we're going to look at is to look at what is the operations on this EtherChannel, what is EtherChannel basically, yeah, and then after that we look at how do we configure EtherChannel. Right. So this EtherChannel still works in our local area network, and it involves our switch layer 2 devices. So the third part is we're going to look at how to verify what are commands to type so that we can see information regarding our ether channel inside our switch. Yeah, and so using those information we can then perform troubleshooting. Okay, so that's the third part. Okay, the first part is the operation of ether channel. Okay, so basically, ether channel is another way of saying how do we combine more than one link. Yeah? If you have more than one link, okay, between two switches, how do we combine this multiple links to act as if it is a single link, right? So there's a on your screen right now, okay? We can see that there are two configuration here, okay? Switch 0 and switch 1 have a single link, right? This is typically how we connect switches together to extend or to scale up our network, local area network. We just simply add another switch, okay? Right? And then and the switch can be remote to each other. That means it's not located near to each other, or it could be actually stack switch. You know, stack switch. Stack switch basically just switch on top of switch on top of switch, and usually typically we see this kind of configuration in medium-sized or larger networks. Okay, no, typically the switches are placed inside a rack. Okay, you can see switch. So um, we can have scenario where the switches are further from each other or they are stacked, right? But they're still physically connected. Yeah. So normal configuration, we have one link to link between two switches, and the ether channel that we're looking at, uh, switches that have more than one link between each other, right? So when you place two link like this without ether channel, what's going to happen is STP will kick in. Recall from last week, we talked about STP is to prevent loops. And as you can see here, when you have two links connecting both switches, loops can happen. And we know that loops is bad for our LAN. Okay, we get broadcast storm and things just start to pile up in the loop. You know, those frames never get away from the network, so it's taking up bandwidth more and more until our network just simply died, cannot function, right? So, but there are reasons why we have more than one link. Okay, the first reason is to provide redundancy, lah, of course, and we've covered this in last chapter. Okay, the second one is to provide larger bandwidth. Okay, now why do we need larger bandwidth between switches? It is because the traffic flowing from one switch to another switch usually carry traffic from multiple hosts. If you think about it, each switch connects to hosts via different ports, okay, on that switch. So the speed between the switch and the host, the link, is usually uh, catered for that particular host. No other host can share that link, the access port, right? But when there's a switch is connected to another switch, therefore the data have to travel between the let's say switch 0 to switch 1. Cannot be physically switched already because it has to go out from the switch, travel through a link, enters the other switch, right? And if the speed is the same, let's say your host to switch is 100 megabits per second, and switch to switch also 100 megabits per second. But that 100 megabits per second is no longer catered only for that one host, okay? Because it's transporting data from one switch to another switch. Therefore, it's shared depending on your configuration. It's shared among all the hosts connected to each particular switch. Therefore, the 100 megabits per second is now happen to be apportioned to the number of hosts that transfer data between one switch to another switch. That means it needs to connect to another host on the other switch, right? Therefore, we would like to, okay, have higher bandwidth between the switches. Now, if your switch already have gigabit connection, then maybe that is suitable for your configuration. Okay, but what if you don't have gigabit connection, right? So the solution is the EtherChannel, the link aggregation. Aggregation simply means you combine multiple links together, and this multiple physical link is now, when you apply EtherChannel, it now becomes a single logical link, right? Okay, okay. So simply having two links like that without applying EtherChannel will not work because of STP. STP will see two links. Two links can produce looping. STP kicks in, one of the link will be disabled. Remember, there will be a election happening, root bridge, root port, all this that we learned in the previous chapter, right? So that's why the question there is saying how to achieve redundancy and increase bandwidth, right? Okay, so somehow we need a link aggregation technology, okay, right? So that will allow redundant links, okay, but yet can get higher bandwidth and not blocked by STP. So the technology is EtherChannel, right? So EtherChannel groups multiple physical Ethernet link into single logical link. The STP will, after you aggregate these links, STP do not any longer see multiple physical link. STP will look at it and see a single logical link. Because a single logical link, STP does not detect that will form a loop. Okay, so STP will not perform the STP operation on those multiple links because they are now considered as single logical link, right? Okay, so the benefit is that you can then have fault tolerance, load sharing, increased bandwidth between the two switches, and redundancy, right? Okay, so you can see there multiple links with redundancy bandwidth becomes 200 megabits per second. We double the bandwidth, all right? You can see the circle, the two circle here, that indicates that it is a ether channel. Okay, right. So if you want to increase the bandwidth, okay, then simply attach another link and include that link into that logical link, the ether channel logical link, and suddenly with the addition of another 100 megabits per second physical link, your logical link now becomes 300 megabits per second, right? So it's up to you. How many links can you dedicate to become the ether channel? Then the more links, the faster the logical channel, logical link becomes, right? All right. So ether channel technology was developed by Cisco, right? To group several fast Ethernet or several gigabit Ethernet ports becoming one logical channel, right? So when you configure Ether channel on those links, okay, so the now no longer you will look at the individual physical port, rather you will look at a virtual interface, and it's called a port channel. As you can see here, right? It's become known, this FO2 and FO1 combine together to become an ether channel. Therefore, we no longer look at the individual channel in terms of transferring data between this switch and the other switch. It now is become a virtual interface, and we give it a name, interface port channel 1, right? On this other side, although it's short form, it's actually interface port channel 2, right? So this is what happened in this scenario where you combine two links between on the left hand side to the middle switch and the other switch on the right hand side to the middle switch. All right. Okay. So let's look at the advantages, right? One of the advantage is that once you configure several ports becoming a single port channel in a virtual interface, then you need only to configure that virtual interface. Then all configuration will be copied to individual physical interface or ports, right? Okay, so you can see here, it simplifies your task. Most configuration tasks can be done on the EtherChannel interface instead of individual port. Once those individual ports combine to become an EtherChannel interface, you can configure the EtherChannel interface instead, right? So this means that you less likely to make configuration mistake, because it by just doing some configuration of single interface, which is the EtherChannel interface, and copy it down to all the individual port, then you can ensure consistency in configuration, right? Right. Okay, so another advantage is you don't have to upgrade your switch. Let's say just now, because of the reason I mentioned about transporting data from different hosts on one switch to host on a different switch. Therefore, the channel between the two switches has to be higher bandwidth. If you don't have it, you can use the current ports with the current speed, combine them together to increase, okay, to aggregate their speed. Okay, so there's no need to purchase additional modules or to upgrade your switch, right? So you save money lah, budget on your infrastructure. Okay, and third, load balancing. Load balancing simply means when you have more than one link, the switch is able to aggregate the traffic. Okay, that means it will know, okay, which interface to select so that it is balanced. The load is balanced between the multiple links. If the multiple links already form an ether channel, the switch will then distribute the transport uh, load between all the included links. Yeah, so you don't see any one link overburden. The work to transport whatever traffic between the two switches is now divided equally. So this is called load balancing. Okay, right. So far, okay. Press one if okay. Okay, thank you. Let's move on to the next slides. Right. So yeah, so we mentioned about physical link and logical link. So logical link is virtual, means it's based on software. Okay, so when several physical link is combined together or aggregated together to form the ether channel, the switch will now see, okay, and any operation on switch will now see as if those multiple physical link is now one single logical link. It can't even differentiate if it's between, like, is it for the purpose of forwarding data, right? You don't even see it as a, oh, the hardware link, logical. You just see one link. That's the one logical link that was created, right? Okay, so there might be situation where you have more than one ether channel between the switches. Okay, so maybe you have multiple, or more than one ether channel existing between two switches. Now, if you do encounter this situation, right, STP will work. Okay, if you have, let's say you have two ether channel links between two switches, because now the STP will see two logical link, two ether channel link, right? Two links means the STP will kick in, because two logical link will form a loop, right? So STP will kick in to prevent loops, and one of the ether channel link will be disabled. Right? In that case, you can still have redundancy. Okay, you can have high speed because you aggregate multiple links to form EtherChannel. If you want redundancy, you form another EtherChannel. STP will kick in and decide which of the EtherChannel it will disable, and it will disable one of the EtherChannel. Right? As long as the other EtherChannel, the single logical link is not down, then it will keep the other one shut down. Okay. Once it detect for redundancy, once it detect the other active EtherChannel link is down, then it will STP will activate, okay, the other EtherChannel link to become the redundancy link. It will then traffic will then flow through that. Now, one thing I want to differentiate: when we say the EtherChannel link is down, mean all the physical link inside the EtherChannel link is down, right? Because EtherChannel is formed or aggregated out of more than one link. So it's possible that not all of the link is down. Okay. If only one physical link inside the EtherChannel, okay, is down, the rest simply take over the load. So again, redundancy in there. What you get is the link still maintained, but there's a drop in bandwidth. That's all. Okay. Right? If all the links, all the physical link within that ether channel is down, then you have one single link down, then STP will kick in to enable the alternate ether link or ether channel link. Okay? Can you guys see
Oh,
this?
means
This,
if one link down doesn't mean one interface down.
yeah,
I mean,
yeah, the virtual interface still up because you still have other links within it. Because remember, ether channel is formed out of multiple physical link. If only one physical link is down, simply means that the other physical link takes over the job, the load. But of course, you have a drop down in the bandwidth because one link, physical link down. Okay?
oh,
Yeah. It's only when the whole ether channel link down, that means all the physical link belonging to that ether channel is down, then if you have a redundant ether channel link, then STP will activate that one. Okay, so the good thing is for me lah, it's a double way to ensure redundancy. One is fault tolerance, means it's degrade in a graceful manner, right? And the other one is the using STP to provide the redundancy. Okay, so this is a very good um, sort of way to ensure that your network is always on, or always active, always available to your users. So as a network administrator, okay, if you find yourself in this kind of situation and your users demand, right, the network cannot be down, it's critical, then this is one way for you to provide very cheaply, yeah, very cheap because the cable is cheap compared to the infrastructure device. The switch is so much more expensive than the cable. So if you do have ports available, then you want to do this, okay, to provide all this security and bandwidth, redundancy, security, and bandwidth, and fault tolerance capability of the network. Yeah. Okay. Right. So let's talk about the restriction. There should be a restriction. Is that your interface types cannot be mixed. So if you're working with fast Ethernet, then all the ports involved to form the Ether channel must be of that type, must be of that fast Ethernet type. If you're working with gigabit port, then must be all ports involved in the Ether channel must also be gigabits. You cannot mix and match. You cannot have, and what's on one side is fast Ethernet, on the other side is gigabit Ethernet, as you can see on the screen. Yeah, you cannot mix them. This is the limitation, right? Okay, so that's the first restriction. And the second restriction is that how many ports can you, or how many links can you use to form an ether channel? Well, at the moment, 8 is the highest you can go. So if you have a fast Ethernet, 100 megabits, fast Ethernet, 100 megabits per second, right? So if you have 8, that means the highest bandwidth you can provide for an ether channel using an ether channel is 800 megabits per second. It's not bad compared to a gigabit, right? Let's say you want to save money, it's only 200 megabits per second lower than a gigabit connection, right? So that means you can then still use your investment for a longer period before you really need to upgrade your device. Or you need to maybe purchase modules, right? Sometimes on a switch, there is no place also to place a module. Even if you say, oh, can I just buy a module, not to buy? Sometimes depend on the model of your switch. Some models still have at the back plate, can open and insert a module to provide more ports. But some are quite limited, quite limited. Maybe there's no space already. Okay, so gigabit ether channel, for gigabit ether channel, that means you can have up to 8 also, so it's up to 8 gigabits per second. So it's competitive also if you compare with the 10 gigabits port compared to 8 gigabits ether channel, and also the 1 gigabit against 800 megabits per second is, it's okay it's competitive also you only like missing 200 megabits per second, so okay for medium-sized network, right? And I think for currently most affordable, even business internet connection to make full use of the internet speed, I think is quite sufficient. 800 megabits per second is quite fast, to be honest. Under Unify, this is one of the top speed already for bandwidth. That will change perhaps when we have 5G. 5G is able to provide you very high speed. So maybe one of the things that companies may need to think about is to upgrade to make full use of the speed available, right? Maybe most companies will have to consider upgrading their, when 5G is coming in, right? All right. So the one in main campus, I forgot to check what is our model. I suppose they have purchased for us the latest model, right? Again, next semester you will be doing SCN, right? Advanced Computer Network. So probably you'll be handling our hardware. But this 2960 is the Cisco switch hardware that's available in main campus lab, right? So that switch is, although the limitation is 8, but depending on the model, this particular model only up to 6 ether channels, right? All right. Okay, so this one is about consistency in your configuration. Okay, one thing that you have to remember that between switches you have to configure trunk. Okay, as long as you consistent on the VLAN part, this configuration is from your VLAN configuration, especially two switches needs to transport multiple VLANs, right? You have to create trunk. Okay, and you must remember on both switches, the ports needs to be configured as trunk ports. Okay, between switch and the host, then you have access port. Okay, so must be both trunk port. Again, if you misconfigure, one is trunk port and another one is access port, not only your trunk doesn't work, your EtherChannel also wouldn't work, because EtherChannel was you must have a consistent configuration for EtherChannel to work. So you can see, it says here, group member port configuration must be consistent. Not only consistent, I think it should be correct in the first place. You shouldn't have access port, access mode for a trunk, switch to switch. Access mode is between switch to host. So this one, S1 is correct with trunk. So this one should be trunk as well, or else it's not consistent, then EtherChannel will fail. Okay. Not only that, I think the VLAN allowed. Okay, the VLAN allowed is need to work for the trunk. Okay. Again, as long as you're consistent in your VLAN configuration, your EtherChannel should work without any problem. Okay, when your EtherChannel has problem, check, right? Or alternatively, before you create the EtherChannel, test whether your trunk works. Okay, once your trunk works, should be your EtherChannel works, right? So if better to test incrementally. When you set the VLAN, you set the trunk, the test, then only you set the EtherChannel. So it means you can then ignore that whether you have made misconfiguration on the trunk part and the VLAN part, right? Okay, so if you every EtherChannel that you create, okay, between the two switches, it will create a logical port channel interface, right? So whatever configuration you apply to the port channel interface will apply to all the physical interfaces, right? So if the best way to do this is configure all your physical interfaces for correct configuration, then create the EtherChannel. Then further configuration should only be done on the port channel interface to avoid misconfiguration, right? Right. So here is continuation of that. Each EtherChannel has a logical port channel interface. A configuration applied to port channel interface affects all physical interfaces that are assigned to that interface. To that interface means that port channel interface. Right. So you can, if you know already that you want to apply EtherChannel, okay. So you can do this both on switch 1 and 2. You configure channel the range of the ports that you want to be as part of the EtherChannel channel group 1 mode on, and then the port channel will be created. So select that interface so that you can go inside. Then you can apply your trunking and allow VLAN, right? So when you do it on this, after you create the EtherChannel, you do it on the logical port. All this configuration, this trunk and VLAN 10 will apply on all the physical port that participated in the same EtherChannel. Okay, that's just a way to ensure consistency in your configuration, and you don't make mistakes, right? Because it's consistent, right? Okay, so let's see how we can configure this EtherChannel, right? Okay, so there are three ways, three configuration on the ports that on the EtherChannel port, the virtual interface, right? Before that, we just talk about there are two negotiation protocol. Okay, the first one is PAG-P, okay, port aggregation protocol, And PEG-P is actually belong to Cisco. Okay, Cisco proprietary protocol. Okay, the second negotiation protocol is the link aggregation control protocol, or LACP, right? And this one is from IEEE. Okay, for all points and purposes, the the what they provide, the functionalities of these two are actually the same, right? So let's uh, just pause for a while and say, what is negotiation protocol? Negotiation protocol means if you as a system or network administrator, okay, wants to automate, okay, just like the trunk, to automate certain ports configuration so that the way you set them, they can auto negotiate, and when you plug it in, right, they automatically form the ether channel. Okay, without you having to go and okay, you ether channel manually set this as ether channel port, this one also ether channel ports, you configure manually, right? So auto negotiation based on these two competing protocols. Okay, I say competing because they also both provide the same, but from two different set of organization lah. One is IEEE open standard, one is Cisco proprietary standard. But the thing is, Cisco supports both. Cisco also supports LACP. Now the thing is, why? Because Cisco is aware that people tend to, or some organization would like to have multi-vendor. Means they like to mix and match their product, not only one vendor. Okay, if you study, I think MIS, not sure, is it MIS or IT or something like that? Multi-vendor is one of the way that the organization reduce the risk, okay, of being locked to a particular vendor. They don't want that. They want the freedom. So sometimes, depending on the organization, they want to buy their products from multiple vendors. So if other vendors, they probably don't have a PEG-B from Cisco, okay, they're probably using LACP from IEEE. So Cisco switches do recognize LACP as well, right? But they are both purpose is the same lah, to allow, you can see here, to form a channel via dynamic negotiation between the two switches connected. So that means you plug on end, suddenly if you set the negotiation protocol, the two ports will negotiate, and if successful, both will then form the channel, right? Okay, so let's say you don't want to auto. The normal typical way is the manual or static or unconditional. Okay, so when you set unconditional, the two ports will not send out negotiation frames. Okay, so that includes both PEG-P and LACP, right? So just put channel group 1 mode on, and this will be static or unconditional. Means manually. You don't want the two ports to negotiate.
Is there a default? When you turn it on, was it default static or unconditional like that?
Good question. The one I didn't think of to check what's the default. I always assume that the default would be static because we don't normally want to, when we use switches, we don't normally want to form ether channel. Okay, it's a special case when we want to provide extra bandwidth, or for the reasons I mentioned earlier on. So, from my opinion, the best way I think is for Cisco to provide unconditional or static. Means you have to manually assign, right? But we can always check. I didn't confirm that part. didn't think about what is the default, but a good question nevertheless. Maybe we can see here whether there is any mention. I didn't detect though. Okay. Maybe after this, if there's not mentioned here, maybe you can find out, or I can find out later. Yeah. So which one is the default? Right. So PEG-P, okay, is a Cisco proprietary protocol. Okay. For it says auto magic, or automatic, or without any setting up manually from the administrator, right? Okay, so if you configure the EtherChannel link using PEG-P, PEG-P packets starts to be sent between them, between the ports. Okay, and like I say, if we find the other one is responding in a positive way, it means it is also set um, to accept negotiation, then it will automatically create the two ports will create this ether channel, right? Okay, so this part is basically what the spanning tree will see lah. Now it won't see separate separate. We involve here multiple ports, although we talk as if it's a single port, it's involve multiple ports. Because if you single port ether channel, I guess no point really. So multiple ports, yeah. So then the spanning tree will see those multiple ports as a single logical port, right? Okay, so on top of that, the PEG-P also manage the ether channel. So PEG-P packets sent every 30 seconds. It will check for consistency in your configuration, right? And if there's was a link down, right? Or you add another link, it will notice this and adapt accordingly. So if you add link, then it will then include that link into the load balancing, right? If you drop a link, then it will automatically also adapt the load balancing, right? So now you have less link, your less link for you for the ether channel process to load balance lah, right? Instead of maybe 4, 1 down, 3 left. So now it can only distribute within 3. Or 4, and then you add 5th one. So now it will add another one for distribution of the load. Okay. All right. So it also check consistency. So make sure all ports have the same type of configuration as we mentioned earlier. Right. Now to ensure that the ether channel is working, make sure all ports have same speed. Okay, means fast Ethernet with fast Ethernet, no fast Ethernet with gigabit Ethernet. And then duplex setting is set, right? I think this duplex is by default, okay? By default set. So this one shouldn't be a problem unless you're mixed mode lah, right? Mixed mode means you add in another switch that is maybe the older switch which only have sometimes I struggle to think about a situation where that switch have IP yet still on half duplex. Okay, but who knows? Maybe there is. Okay, I find it hard for manufacturer to provide IP when they can only provide half duplex for the port speed, because we're not talking about hub, right? We're not talking about hub, right? And we're not talking about PC. We're talking about switch to switch. So we're talking about switch. If a switch is providing ether channel capability of PEG-P, it's very hard to think about why that port, unless it's misconfiguration, that port has a half duplex setting. Okay, so by default, if you don't touch any of the duplex setting, I think suppose changing to half duplex. I'm not sure why you want to do that. Okay, but normally this one should be no problem. The VLAN information is what does the port belong to? Which VLAN does it belong to? It means either if it's a trunk, then you can specify the list of VLANs it's supposed to handle, right? So this one must be correct for both port. Right? Now you can see that it says any port modification after you create the channel or the creation by auto negotiate also will change all other channel ports. Right? So you ensure this ensure that there's consistency. So one misconfiguration on one port will be spread to other ports as well. You have to be very careful when you are configuring an Ether channel port. Okay, so PEG-P operation, we have three state. One is on. This one is the this one. Channel group one, mode on. Mode on is the on here. It's manual. It's basically you're forcing the interface to form the ether channel without the use of PEG-P. You don't need, because you're doing manually, so you don't need negotiation. So there's no need to use PEG-P, right? So that's why it says if you switch on the on mode, okay, those interface no longer exchange or no longer generates PEG-P packets. No PEG-P packets are flowing between the two switch anymore. The second state is PEG-P desirable, right? Desirable means that port you set as desirable will send PEG-P packets. It is actively trying to negotiate with the other port on its link, right? So it is sending PEG-P packets, right? On the other side, if you set it a PEG-P auto, then it is a passive negotiating. Means it will not send packet, but it will receive packets and interpret it. And if it's in auto mode, if negotiation check everything okay, then it will form the ether channel link, right? Okay. So later we'll see the table, the table. So from the tree here, you can sort of create a matrix table, uh, the different scenario or different pattern that you can create. Okay, so on or desirable on or desirable auto. This can, because you can configure it, right? So if you configure it wrongly, you might find that misconfigure, then you might find that your ether channel is not forming, right? That's why it says here, the modes must be compatible on each side. If one side is configured to be in auto mode here is waiting for negotiation packet. It is placed in a passive state. So that means if you also set the other port to be auto, both are waiting. None are sending of this. None are sending the PEG-P negotiation what uh, packet. So if they're not sending, they're just waiting, then ether channel cannot start. So yeah, cannot start lah. Ether channel will not form. If you set no, of course, no mode configured, then it's basically disable mode. Okay, the on, as I mentioned, is manual, right? And on mode will this one will set without any negotiation. Means you have to set both on, both side. If this switch on, this other switch on, because on mode does not send also the negotiation. So we switch one on, since the other one, if you say it's auto, right, then it waiting for packet is not going to receive, so it's not going to set itself. If you're desirable, it's going to send packets, but since you're on, you're not handling any packets. Means even if you receive, you're not going to care. So the other one also doesn't receive the acknowledgement to negotiate to build up. Then it will also be disabled. It will not, the internet. The ether channel link cannot form. Right. So if you set on, must remember the other side also set on. Okay. So both switch must set on. Okay. So no negotiation means no checking, means they're not, the one I explained, they're not going to check, right? They're not going to check. There's not checking, then no EtherChannel will form. Right, so this is the matrix I was mentioning, combination, yes and no, okay? So if your intention to have EtherChannel, when you are troubleshooting, check the configuration for both switch 1 and switch 2. Okay, if you can remember this combination, good lah. But if not, come back to this combination to check, right? Check on S1, check on S2. Both must be on. Okay, yes. If no, right, then you check. Is it on? And then the other side not on. Either desirable auto, it will be no. Right? Or both auto, it will be no. So if you check why EtherChannel not forming, if you try to negotiate, right? Let's say the question say, oh, we set like why is the EtherChannel not forming although we already configured? Here is the EtherChannel, show EtherChannel info. Then you check, right? You detect, oh, auto, so one auto, of course, no. So what can you do to make it, right? If you maintain auto, you choose which one is auto, S1 or S2, and which one is desirable, right? You can either change it to this, or change it to this and this, or set both on, not this one. Set both on, right? Okay, so like P is actually very similar to the Cisco negotiation protocol, but this one comes from IEEE. Okay, same IEEE that looking after our Wi-Fi protocol, our Ethernet cable protocol, and so on. Because IEEE usually works on layer two technology or layer 2 specification. So because this is also layer 2, right? Switch to switch. So that's why it's under IEEE also has this negotiation. This one is open standard. Open standard simply means that IEEE, when they set up this specification, they have RFC or request for comment. They place it on their website and then invite comments from industry experts and sort of things to make comments before they release that version as the stable version. So that specification becomes the specification or protocol for any manufacturers to, when they want to build their switch port negotiation part, then they will follow it, right? Okay, so again, why there are two? Because, well, Cisco always provide their own proprietary, but they also understand some organization is in a multi-vendor environment, right? So they also will support, right? So you can see on Cisco devices, both protocols are supported. Again, there are 3 states that you can set for the port on the switch: on, active, and passive. The names are different a little bit. This one is active passive, this one is desirable auto, right? But they are the same, right? You have active and passive negotiating. So the explanation also the same, okay? So the same as the one for the Cisco proprietary PAG-P and LAC-P is the same, right? And also, when we look at the matrix, when we compare, they are also the same, right? Just the name different. The on the same, but the active passive replace the desirable and auto. Okay, you set as passive, they both waiting. Of course, no EtherChannel will form. Passive active, yes. The active will send the packet to passive. Passive will then activate, activate, form. same as this one. Active will do. Okay, active, yes, will do. On, as long as you're on, is not sending, is not receiving. So no matter active or passive, you set the other side, still will know. Okay, and vice versa. For on, both must be on. Manually switches on, right? So you might ask, before we move on to the next section, which is configuring the Ether channel, you might ask, which one should I choose? It depends. If you're a single vendor, all of your switches you buy from Cisco, then safe to use pack P lah, right? Pack P. Okay, and if your network, you confirm you're not going to change your topology, okay, or you hardly ever change topology, setting both to on is usually safe bet, right? Okay, if you're a you support, or your organization, okay, support multi-vendor, so most probably you should choose like P, right? Like P, so that the because since Cisco also support like P, other vendors support like P, then they can interoperate. Okay. Any question before we move on?
No.
Previously is what?
Previously, sorry, Noel.
Spec P. The previous matrix. Is it Spec P?
The previous matrix, you mean this one? Spec P?
Yeah. Oh,
Yeah,
Spec
this
P.
one is Spec P. This one is for the Spec P from Cisco. This Spec P is proprietary to Cisco, their protocol. Okay, but it functionality wise is the same as like P. You can think of like this: you have Intel chip, you have AMD chip. They are two different vendors. They have two. If you look inside the CPU, the circuit, all different, but functionality wise, okay, functionality wise they are same. Why I say that? Because if you run a program, you run the OS and program under AMD chip or Intel chip, both can run, right? But the implementation is different. So like P and PEG P, right? The same thing lah. They are from different vendor lah. One is IEEE, which is I think they are not for profit lah. IEEE is not for profit. Okay, they do a lot of they work on a lot of open standard, because no matter what, industry still think that open standard is good, right? Open standard is like open source. Open source is for software, kan? Open standard is cover much more than open standard, open source lah. Open source only software, but open standard covers the protocols for networking lah, or other things as well, right? Even remember, if you're doing your COA, right? Even covers the way your floating point is, is stored inside the computer. So they even go into that, right? So they're both the same. I mean, if the only reason why you want to use PEG-P is if you're a single Cisco vendor, every switches, also every routers, all your intermediate device comes from Cisco, then yeah, why not, right? But if your organization is multi-vendor, means you buy some from Cisco, some from maybe other places lah, D-Link or Lucent or any of the networking vendor, maybe even Huawei kan. So they probably implement the like P, right? They cannot use PEG-P because PEG-P is proprietary to Cisco. Now, if you want to use PEG-P as a vendor, apart from Cisco, I think you have to negotiate a license. Okay, license with them to use, so you pay license fee, right? Just like your vendor for your PC, like let's say Hewlett Packard. Hewlett Packard wants to provide PC, but cannot just simply give to normal people. Cannot simply give you without OS, right? So they want to provide OS, because if you buy laptop car, you buy PC, right? You want straight away can use. So they provide OS, but the OS from Windows, although it seems free to you to buy the Hewlett Packard laptop or personal computer, actually Hewlett Packard already pay the OEM license fee to Microsoft, and they will just simply push the cost to you, right? It's already part and parcel of the price of the thing that you're purchasing, whether laptop or your desktop PC, right? So proprietary is like that. Okay, that's why IEEE comes in, is to provide open standard. In fact, our network now, okay, is based on open standards. Last time, before you guys be a time, yeah, I still remember when I was you guys about younger than you guys. I remember people actually, some companies actually have to purchase, right? Have to purchase license or how to purchase network, right? Can you imagine that? The network you want to form in your local area network, you have to pay as a business. Because at that time, it was not mature yet, the TCP/IP stack, right? So the most popular one at that time is the NetAware, I think. NetAware, right? So yeah, you buy a big box, inside got a lot of CDs, you install on all your workstation and your server. Then when you connect them, then network can flow. Different from now, right? Different now. Now Linux, even Apple and Windows and other OS all using the TCP/IP, right? And that is open standard, so it's free. So the moment you install your OS, you connect all your hardware, you have network for free. Don't have to pay, right? Okay, so even Wi-Fi is under IEEE, so it's free. It's open standard. Right. So if no questions, we move on to the next section. Right. So the next section is configuring EtherChannel. Just now we look at the operation of EtherChannel and all the benefits, difficulties, and whatever. All right. Then now is you go inside the switch to configure. Okay. Right. So guidelines and restrictions. Okay, all Ethernet interface must support EtherChannel with no requirements that interface be physically contiguous. What does it mean, physically contiguous? That means the port does not need to be beside each other. You know, contiguous means the port have to be, let's say, because on the port you have ETH0, ETH1, ETH2, or FA01, FA02, FA03. Contiguous means one after another. You have to use the port that is close to each other. But he says here, no requirement that interfaces be physically contiguous. As long as it's the same type. If fast Ethernet, fast Ethernet. We don't look at the port now. And they don't have to be running number, means whichever port is free. Okay? And then it depends on your configuration, which of the port occupied by the cable that you connect the switch belong to which Ethernet channel you configure, right? Speed and duplex, configure all interfaces in the EtherChannel to operate the same speed and the same duplex mode, right? So this one I think shouldn't be a major problem. This one should be no problem at all, I think. Yeah. On the switch, of course, you maybe a multi-vendor, maybe multi-vendor or multi-model. Older switch maybe only up to 10 megabits per second. So you can't mix and match, right? Different speed. Okay. And duplex and half duplex. Again, this one, even the slower speed switch, okay, all operate in duplex mode. only hubs, I think, operate on half duplex. So far, I haven't seen modern switches operating in half duplex mode. Right, VLAN must match. Okay, must be assigned to the same VLAN that can be configured as a trunk. Okay, and I'm pretty sure it has to be configured as trunk because only a trunk can allow multiple VLANs to travel through the link. Okay, if you don't set as a trunk, then only one VLAN can travel to it, or only the native VLAN can travel to the trunk to the link between switches, right? So your set of VLAN allowed to travel through the trunk at both sides of the link must be the same, right? Okay, so the same is here, right? Right, so here we got a figure that shows the configuration. So speed match, duplex match, VLAN match. All right, so this is VLAN 10, VLAN 10. So VLAN 10 is not trunk, right? Okay.
Can there be two interface between two switches?
Can there be
Virtual interface.
virtual interface? Virtual interface. Virtual interface as in the multi-layered switch, is it?
Yeah.
Multi-layered switch. I haven't seen that configuration before this. Meaning to say, I'm pretty sure can. If your multi-layer switch, you dedicate more than 2 or 3 ports become virtual interface, so that you can route the VLANs. I'm pretty sure can. Then you operate on the single logical link, right? That means your EtherChannel link, the single logical link becomes your virtual interface, right? I think this is what it means for routed port. Am I answering the correct question, Noel?
Yeah.
You're talking about multi-layer switch, yeah. I think so, definitely. Because once you form the EtherChannel, what will be seen by the router then will be the single logical link. Just like STP will see single link, the multi-layer switch will see that single logical link. So that single logical link can be set as the routed port, becomes as virtual interface. Right. Good question. Good question, that one. All right, so let's move on to the next one. All right, so this is a steps to configure EtherChannel with LACP, IEEE protocol, negotiation protocol. Right, so there are 3 steps. Step 1, specify which interface to compose the EtherChannel group. Right, so you use the command interface range fast Ethernet. Okay, to create the range lah. Has to be more than one, or else your EtherChannel has not really a good functionality, right? Okay, and then after that, create the port channel interface, right? Using this command, channel group 1 mode active, right? Then active, because this is the keyword used in LACP. Okay, manual put on, no disable. Okay. So the other one, if you use active, the other side of the link also active or passive lah, right? So that both also can negotiation will become correct, will on. Okay, right. So if you use what was it, desirable instead of active, then you're automatically not using LACP. You're using PAGP, which is the Cisco version. All right. Okay. So step 3, change the layer 2 settings on the port channel interface. Enter the port channel interface configuration mode using the interface port channel command. Right? So type interface, we exit first lah. Okay, then you go into config interface, interface port channel 1, then you set trunk mode and allow which VLANs. Switch port trunk allow VLAN. So that means because you set this after the interface port channel, because it's the interface port channel consists of these two, fast Ethernet 1 and 2, then both these physical interfaces will have these two settings, right? Is your configuration. So only type one time and then both set. Okay, and then you do the same for S2 if you are doing on S2. This is for S1. Okay, for S1 you can remain with active or you can put in passive. Okay, right. Right, so I think this one refers to what we're going to do for our EtherChannel packet tracer exercises lah. Right? So you can also do this exercise on your own if you go into our NetAcad resource on the internet lah. Yeah, so you can do, okay, or you can do this on your own. And then we also have EtherChannel packet tracer practice in our practical later this week. Right, so next we want to see and how to verify and troubleshoot EtherChannel. So when EtherChannel that you're trying to configure doesn't work, why? Okay, how to check? Right, so the commands that is very important for verifying EtherChannel is this lah. Show interfaces port channel, show EtherChannel summary, show EtherChannel port channel. What we put port channel because you may have more than one EtherChannel. Okay, you may. So that, okay, which port channel you want to see. Show interfaces, EtherChannel. Okay, all these four can provide you the what, or you can try this out in our practical, or you can, if you can't wait for our practical on Wednesday, you can check it out. Check it out first from online lah, right? Okay. Right. So things to, this is a checklist that you have to tick. Let's say you are you're troubleshooting. So these are the type of common issues or errors that can occur lah, right? All interfaces within an EtherChannel must have the same configuration of speed and duplex mode. Native and allowed VLANs on trunks, access VLAN on access ports. That means you have to ensure the configuration all correct lah for this part, right? Okay, means they're consistent, all consistent. All the ports involved in the EtherChannel must be consistent configuration, right? So misconfiguration that can happen that cause EtherChannel problems are like this lah, listed out here. These are the things that you have to watch out for. And sometimes in the scenario given to you, they purposely put this kind of errors. So waiting for you to check and detect, right? Let's say the assigned ports for the EtherChannel does not belong to the same VLAN or not configured as trunk, right? Or they have different native VLAN. Okay, and all these problems will not allow EtherChannel to form because it's considered as misconfiguration, right? Trunking only configured in certain ports. certain ports misconfigured, no trunking or set as access mode, right? So problem. One way to avoid this is form the ether channel first, then configure trunking, right? When you do this, whatever you configured on the ether channel link or port, okay, will be applied the same to all the physical port that makes that ether channel, that forms that ether channel. That is the better way lah. Because this one, set one time, all the ports will follow through, will follow the configuration. Therefore, you will not less likely that you will get misconfiguration unless the main configuration you do here, then there's a real problem with that. I think should be okay, right? If you ensure your trunking and inclusion of VLANs is correct, you apply on the EtherChannel interface, then all the physical interface that forms the EtherChannel will follow that configuration. Then you shouldn't have different trunking VLANs, whatever, configured on different ports. Okay, you won't have this kind of problems, lah, right? But sometimes they purposely, in the question, they purposely do the configuration individually, make some configuration wrong. Sometimes they don't show you the configuration question. The configuration commands. They show you the show using the show ether channel information or show VLAN interface, information, and you need to be able to know how to look through those, sift through those information to detect this kind of errors, right? Another thing is the allowed range of VLANs. The set of VLANs you allow for those ports that you include as part of the ether channel. They all must have this. They must all, because ether channel will do load balancing. You cannot do load balancing if one port only serve VLAN 1, 2, another port serve VLAN 1, 2, 3. So let's say the switch receive VLAN 3. So now how can it load balance, because one of the port does not support VLAN 3. So that's why it's not allowed. That's why all the ports belonging to the same ether channel must support the same VLAN range. Okay, so if you plan to support VLAN 1, 2, 3, all ports belonging to that same ether channel must be VLAN 1, 2, 3, so that the ether channel can distribute the load, right? All right, so dynamic negotiation option, whether you're using PEG-P or LAG-P, not configured correctly lah. Remember the two no's in the matrix. Okay, because the yes, there's no need to troubleshoot. The yes, all okay. But the two no's for both PEG-P and LAG-P, right? The two no's that form. Okay, if both are listening, cannot form, right? If one is manual and one is auto negotiate, whether active or passive or desirable or auto, it cannot form. Okay, just these two options. Okay, when you detect these two options, either one can happen, right? In the configuration, then you know why, right? That's this part. Okay, right. Troubleshooting ether channel example. In this figure, we have interface F1 and 2 for both S1, S2 forms an ether channel, but this ether channel is not working. It's not operational, means it cannot form, right? Okay, so we use this command show ether channel summary, right, to detect lah, right? The output shows that it's down. Okay, so where do we notice? This one, this one, this one. Okay, down, SD down. EtherChannel down. Okay, detect then it's down, right? Okay. So that's how you straight away know, okay, my EtherChannel not working is down, right? Then Viewport channel configuration. Then you type show run and then filter with begin interface port channel. Okay. Then you can see the output. Okay, this is the command we provide. And then on S1 and S2, same command. We detect the negotiation PEG P modes, right? Okay, so here, mode on, right? And S2 is desirable. What happens on and desirable? It's one of the
Off.
condition, right? Noel? Yes, Noel?
Off. Sit off.
Yeah, well, it cannot form. It cannot form the ether channel. These are the one of the condition that it wouldn't form. On one side is on, so on means manual. No PEG P packets will be sent out or received, because even if it reach the on port, it will ignore it. Okay, neither will it send out PEG P packets. Desirable means it will send packets. So on this side, S2, it's desirable, it's sending out PEG P packets. But when it reach here on S1 is ignoring those packets because it's manual on. If you still want to remain desirable this side, then here must be set to either desirable or auto. Or if you want to remain on for S1, you have to set on for S2 as well. Okay, that's what means incompatible PEG P modes. Okay, here and here. Right? So correct the misconfiguration, right? So in this example, PEG P mode on the ether channel is changed to desirable, right? So both desirable, right? Both desirable. EtherChannel and STP must interoperate. For this reason, the order in which EtherChannel related commands are entered is important, which is why you see interface port channel 1 removed and then re-added. Remove, usually you put no shutdown, no shutdown, right? Why? We have to bring it down first so that we can do the configuration. Because we try to immediately make changes to it, right? It will not be ether channel. It will be how to say this? It will be detected by STP because it's not forming ether channel yet, right? So if you don't want STP to come in and disturb your configuration, you have to shut down those ports, those interface that you want to configure as ether channel. When it's down, you can do your configuration. STP will not detect. Once you're ready, you bring it up. Because if it's not ready and you're doing configuration, it's not ready yet, it's a channel not formed yet. But since it's two link, and when switch is up, its state is up, STP will see it as two separate physical link, and STP will then go and shut down one of it because of the loop. This is what it means here. Okay. This one, any question on this part?
Maybe need digest.
Sorry, Noel, your mic is very soft,
Need to digest.
Oh, need to digest. Okay. How about Farah and Kelvin?
Yeah, Sam. Need to digest first.
Yeah, it's a lot of info, this one.
All right. Okay, let me know if for me digest means you need to
Need to read it again.
reread again, right?
Maybe, yeah.
It's not the same as don't understand, huh? If you don't understand, different from that, no digest. If don't understand or something that not clear, you have to let me know.
Okay.
Mm. All right. So I just before we move on, I just cover back this one. What it means here, the note here is this is for practical reason. If you are doing EtherChannel, what you mean, what is happening is you're connecting two physical link between or more between two switches. If it's not set as EtherChannel yet, there is no single logical link yet. So STP will see it as, if both are up already, STP will see it as two physical links. So STP will step in to prevent looping. It will step in and one of the link will be blocked on because of the STP operation, which we already know will happen, right? So better if you don't STP come in and disturb you while you're doing the configuration, shut it down first, right? Shut it down first. Do your EtherChannel configuration. Then for testing, you bring it up, right? If it's successful, STP only detect because EtherChannel becomes EtherChannel, right? The STP will not try to block any of the physical port because it will see it as single logical link. That's what it means, right? Okay, the order of how you are doing certain things when you're configuring EtherChannel. Okay.
So why the run the command 2 times, like interface range F01, 2, and then no shutdown. You do 2 times.
2 times. No, you did it.
What?
You mean what?
This on the comments.
The channel is different.
This one different. This one is different. You mean?
I mean, yeah. Wait.
Oh,
Never mind. Maybe next. Yeah. The comments are like run 2 times. So yeah, that's why I don't understand.
oh, the comments
Channel group 1.
do twice. Let me see. Which the note is it? The note here. And for this reason, the order in which is why you see interface port channel 1 is removed and added the channel group command, right? Desirable, as opposed to directly change. You say no interface first and then bring it up. If you want to try to change configure to CP errors, it's double command. This one double command, is it?
Yeah, that's what I mean.
1, 2, mode desirable, no shutdown. F1, 2, channel group 1, mode desirable, no shutdown. Exit. So this one, in the first place, interface, and then desirable, no shutdown for S1, and no shutdown, then exit goes back to config, then interface, channel group 1 more desirable, no shutdown, spot channel 1. Switch port mode from. Oh, I see. You're saying why do we need to do both twice, right?
Yeah.
The only difference is this part, no? But this part is only for the mode trunk. This one, remove it, do this, and then straight away update. I'm not sure this one why is twice. It's the same command.
Oh, never mind lah. Maybe
Yeah.
typo.
I don't understand also why they do twice. I see whether I really thought it was like you disable first. I mean you disable, you do, and then enable, you do, or something like that. But still, this actually is the same, right? Didn't really look at it properly. Let me just remove the. Yeah, I only highlight this and this, but this two, to be honest, it's also no shutdown. No shutdown. Maybe it's supposed to be shut down here. And then it makes a difference, but no shutdown means it's also up. Okay, so I will find out this one if there's any mistake here for you guys. Okay, but for now I can't see why the two. You're correct. What I don't know why it's just two twice.
What is it? The creating a port channel? Maybe because it needs to like uh double the command, because the first one is creating a port channel, and then in it I also don't know, because I saw the creating a port channel interface, port channel 1, and then he
Yeah,
said no shutdown.
yeah. That means this one, right? Creating channel group one mode desirable for F1, F1 and 2. But then we see this again. Same thing, and also, then also we bring up, no shutdown, we bring up. So basically the command here do it twice, cannot, and there's no difference. So that is the confusion here lah. I think so. Yeah, so fairer, yeah, there is a message here saying creating, but if it's already created, why create again? It's not for S2, it's for S1. Both also S1, right? So let's say this one is a response from iOS. Once you say channel group one mode desirable, so that okay, it's created, and then you bring it up. Then you exit, come back in, and you redo it again. This time there's no information already, because since it's already created and it's already up, you basically just replicated the command. Is it just to ensure, to confirm to yourself whether you have created? Second time creation, no more message received from iOS.
Oh, ya kan?
Yeah, so that's the only, because if we're talking about this one, it's actually talking about this and this. Yeah, the information from the node interface port channel 1, and then you bring up interface port channel 1, right? The only reason I can think of lah, to just double check, make sure, and you type twice. Apart from that, there's no other reason, I guess. Yeah, maybe during our practical we can try this once and twice, see whether any difference. But I think no difference lah. Just to double check, I guess lah. Right? Maybe if any of you want to try out, also can update us also later. Yeah, on this issue. All right. Next, to verify EtherChannel is operation, show EtherChannel summary. Then you can see, let's see, P bundled in port channel means that particular port belongs to a port channel, means it belongs to an Ether channel. So we know it's active. So here, and the protocol used to connect, to actually bring them up and bring them together as Ether channel is this. It's being used, right? And the port channel that these two belong to is this one, P01. Okay, so when you see this, then the Ether channel is active, it's working, right? That means you fix the problem. All right, so packet tracer again. I think this exercise exists in your NetAcad online. Module practice and quiz is basically I will unblock it, not unblock. How do I say? I will enable it. Yeah, I will enable in the NetAcad, right? Okay, for module practice for EtherChannel, I will enable it. I think the VLAN, inter-VLAN routing, and STP already enabled. Please let me know if it's not. You can use the resources, the chapter exam, which is MCQ. So just find some time during your busy time. Find some time when you're not being disturbed, when you have some free time, even night time also no problem. Then you try to do the exam, chapter exam, which is MCQ. So it's also one good way for you to practice your revision. All right. Okay, so implement EtherChannel also. I think it's part of our practical and also packet tracer available online. All right, so build network, create VLAN. All right, so this one is a combination to build up your knowledge. If you have this on the NetAcad, please try to do it because we have already done this part. We've done this part, right? And then instead of the inter-VLAN routing, we do this EtherChannel between switches instead, right? Okay. All right. So, okay, you guys read this ones yourself because this is what actually our topics inside. Just a summary of what we learned already, lah, right? In this chapter, right? Okay. So that's it. That's it for the lecture. Let me just stop our recording first. Okay. So I will see you guys in our tutorial meet. Okay. And this afternoon, you do revision. Please do check our what we have done in our STP tutorial. Make some notes there, additional notes, and also as correction, right? Use the 1 hour tutorial as your revision practice. Try out the exam questions only up to STP, yeah, right? And I will be monitoring. Okay, if you have any question, message me on our meet link. So okay, I will see you guys in the tutorial meet. Now just take a 10 minutes break lah. Right, I'll see you in the tutorial meet.
Okay.
All right.